Hi, I'm Nitin. Today we'll be learning about the application of lasers in plastic welding. We'll be going through the what is plastic welding, types of plastic welding techniques, and we'll be concentrating on the laser plastic welding, which type of plastic can be welded using a laser, and the types of laser plastic weldings. What is a plastic welding? Plastic welding is a process of creating an molecular bond between two compatible thermoplastics. Welding offers superior strength and reduces cycle time. In plastic welding, it is applied through a convection of the pincher tip instead of a conduction. The two plastic pieces is brought together at the time of welding. A jet of hot air is liberated. This melts the part to be joined along with the plastic filler rod. There are three main steps to any weld: pressing, heating, and cooling. Plastic welding processes are primarily differentiated by their heating methods. The application of force and allowance for cooling are mechanical consideration, which may vary for machine to machine within the general process category. There are several methods of plastic welding. Now, the types of plastic welding: hot gas plastic welding, hot plate plastic welding, ultrasonic plastic welding, friction plastic welding, and laser plastic welding. Now we'll see what is a laser plastic welding. When laser welding plastics using the transmission welding method, two types of thermoplastics are joined with one another. The laser passes through the transparent mating part, and the observing mating path is heated. The observing plastic melts the transparent joining area. The mating parts must be pressed together using a suitable fixture in order to ensure sufficient heat is transferred. As far as possible, the gap should be smaller than 150 μm here. In order to ensure the permanent connection, the melted plastic must solidify completely. The fixture therefore continues to press the two mating parts together for a given holding time after the actual welding processes. Which plastic can be welded using a laser? The weldability of the various material is shown in the material pairing matrix. Plastics of some type have the highest level of connection stability after laser welding. If the plastic contains high proportion of glass fiber, this may result in somewhat brittle welding connection. It is therefore recommended that a glass fiber content of 40% is not exceeded. A laser transparent material with glass fiber should not be thicker than 2 mm. Types of laser plastic welding. Contour welding. During contour welding, round parts in particular are rotated at up to a 25 meter per minute under a laser beam. The contour to be welded here is traveled along and heated up with the laser beam. Beside round parts, large three-dimensional components are also ideal for counter welding. The biggest problem with this process is that stress may occur in very bulky component since the contour of the component to be welded is not heated simultaneously. Simultaneous welding. In the case of simultaneous welding, the laser beam is formed so that it adapts optimally to the component. In this manner, the contour to be welded is heated simultaneously. The result is very short process times of only around 100 ms. Components that have a low level of complexity and are produced in high quantities are particularly suitable for this process. However, if the component geometry changes, the form of the beam also has to be adopted. Quasi-simultaneous welding. In the case of quasi-simultaneous welding, a scanning laser beam eats up the welding contour. Since the laser beam circulates at up to 15 meter per second or 900 meter per minute, it works so quickly that the contour is heated almost simultaneously before it has the chance to cool down. The programmable focusing optics allow you to react to changing welding contour quickly. This is a clear advantage compared to simultaneous welding.